Hello again, everyone from CodeYourFuture. It's me, Luciano, and in this screencast, we're going to be finishing the password verifier Kata, which we started in the previous screencast. If you haven't checked it out yet, I would recommend you to do so because in the first part of the Kata, I am talking through some of the foundations of the test-driven development, also known as TDD. And in the second part, we're going to be implementing the rest of the features of this Kata, and it's important to understand what we've done in the previous episode. So the links are going to be in the description of this video, and if you haven't checked it out yet, go and see the first part of the Kata. Okay, before we proceed with the second part, let's do a quick recap of what we did on the previous screencast, which was essentially this first item or this first feature, which it basically includes adding the validations with custom messages for each error of the password verification. So let's check it out, our tests, and see what we did. These are all the tests that we wrote for the Kata so far. And for each of them, we are basically calling the verify function on the password verifier class, passing some passwords to it. In this first test here, we're passing no. In the second test, we are passing some random password. And for each of these tests, we are asserting, or we are checking that we are throwing specific errors. So in this previous test, we are checking that we are throwing an error which says that the password should not be no, and that's why we are passing no in the verify method. In the second test, we are basically passing a password with a length of 8 characters, and our rule was that the password should be larger than 8 characters. And we go along and test each of the assertions, or we test each of the rules of our password verifier class. All right. So if we go back to the description of the Kata, in the second episode, we're going to start by implementing the second feature, which is that the password should be okay if at least 4 of the previous conditions is true. So once again, we had 5 conditions previously, and now what we need to do is make sure that at least 4 of them, no matter which order, but as long as 4 of them passes the validation, then our password should be valid. And if 5 or if all of them fails, then we should throw the error explaining which failures we had. Before we proceed with the implementation, let's run all the tests again, just to make sure that we have everything still working fine, as we did in our previous episode. So I'm gonna run the npm test, passing the password verifier to it. And as you can see, our test still passes. So we are ready to continue. Going back to our implementation, let's see what we did so far. And we had the password verifier class that goes these first 9 lines here. And this password verifier class has one function called verify, which receives a password as a parameter. And we are running each validation in sequence, and whenever a validation fails, we are throwing an error with a specific message. Okay, so how can we modify this code to make it passes at least 4 validations and only fail if all of them fails? So the first thing as we do, as we already studied in the previous screencast, is start with a test. I'm just clearing my console screen here. So going back now to the editor. So again, first thing we're gonna do is start with a test to check that at least 4 validations should be okay. So let's start by writing a test here, and I'm gonna write password should be okay if it passes at least 4 validations. And as we did with our previous test, I'm gonna pass a function because that's how Jest framework behaves. That's how we write tests with Jest framework. And I'm gonna continue with the expect function from Jest, and I'll pass the password verifier again, dot verify. Now it gets a bit tricky because we have to pass a password that passes 4 validations but fails in one of them. So in this last test that we wrote in our previous screencast, we wrote a password that passes all the validations. So what we can do is write a password similar to that one. So by typing anything here, the password's not gonna be null. I'm gonna type an uppercase letter, so this passes the uppercase letter validation. I'm gonna continue with lowercases, so now we get another validation passing. And what I'm gonna do is type 9 characters. So this is gonna pass also the password length validation, but I'm not gonna type any number. So this should fail the number validation check. But because it passes other 4 validations, we should not receive any error. So our password should still pass. Our password verification should still pass. So what I'm gonna do now is save this change, save this test. I'm gonna run it for us to see the test failing as we did in our previous screencast. And we're gonna make it pass after that. Alright, so as we expected, our test fails in this last test, and the message is at least is exactly what we expect it to be, that the password should have one number at least, right? So this is what it says right here. Instead, we expected the function not to throw any error, but instead we got password should have one number at least. So let's go back to our code. I'm gonna clear my console again. And let's go back to our code and make this test pass. So let's go to our implementation. And once again, let's see what we have so far. And as you can see, for each function or for each validation, as soon as this validation fails, we throw an error back to whoever is calling the function. But if we are to allow 4 validations to pass and only 1 to fail, which is basically what the feature is describing, we cannot proceed with this approach here. What we have to do instead is accumulate the errors and then check the number of errors that we have, and if we have passed this limit of 4 validations, then we're gonna throw an error containing the message that we have accumulated so far. I'm gonna create here a constant to explain better what I'm thinking of. So let's create a constant called validation, and this constant is going to be an array. Okay, what's going to be inside this array is all the validations that we want to go through. So I'm going to put the validations here. I'm going to format this code. And I need to put the comma because it's an array. So that's formatted again. Okay. Now, if we run the test as is, everything is going to pass. And the reason being is when the array is being interpreted in JavaScript, here inside we are still calling each function with the password parameter. So each function is going to be called, and if any of these validations fail, then the exception is going to be thrown. We can even save this and run the test again, just confirm our suspicion. So as you can see, all the validations that we had before still pass, apart from the one that we recently wrote, which is the one that we want to make it pass, which is the new feature that we are adding. So let's go back to the implementation. And what we want again is to accommodate each of the errors. So for this, we are going to be removing the parameter of each function. And the reason I'm doing this is because I do not want to execute these functions inside of the validation array. Okay. Remember, each function here, or what we've been calling functions so far, is in fact a constant. So constant not null. If you go to line 19, constant larger than 8 characters. And the value of these constants are actually a function inside of it. Okay, so that's why we see here constant larger than 8 characters equal a function. And what I mean by this is, if I'm just putting these constants here or referencing them, the function will not be executed. So I'm gonna have a reference to the function, but I will not get the result of this function because this function have not been executed. I have not passed any parameter to these functions. Only when I pass the parameter to these functions, they're gonna be executed. Also notice that I didn't remove the parameter from the not null function. This was actually on purpose. So as we discussed on a previous screencast, the not null validation is the most important that we have here, because if this validation fails, none of the others are gonna pass, because we cannot have a password that's larger than 8 characters and it's at the same time null, or we cannot have a password that contains number and at the same time is null. So there's no reason for us, in fact, to have this validation inside of the array, because this validation must always pass, otherwise all the others are gonna fail. Okay, so I'm gonna maintain it here outside the array, and the validations that I'm gonna keep inside the array are the other ones that may or may not fail. Alright, so now that I have the validations inside of the array, what I want to do is go through each of them, execute them, and accumulate the errors, or collect the errors, and only after I have the errors collected, then I'm gonna check which errors I have, or the number of errors I have, and then I'm gonna throw the errors if the number of the errors that I have exceed the allowed number of errors. Okay, the way that I'm gonna do that is having another constant called errors, which is gonna be the result of these validations. So I'm gonna take the validations, I'm gonna map through them, And for each validation, I'm gonna execute them with a password. Okay, so now I am passing the password as a parameter to the validation. Now the validation is going to be executed. Now I'm going to have the result of the validation, which may or may not be an error. Okay, so I'm going to put this map here in a new line to make it easier to read. And let's carry on here to these validations, because it's going to be a complicated refactoring to do, right? I'm going to walk you through each of these steps very slowly so we can understand my thoughts and the reason that I'm doing this. So if we maintain the throw errors on all of these functions, we're gonna have the code or the function verify stop executing whenever the error happens, as we currently have in our code. But again, we want to accumulate them. We do not want to throw them immediately. All right? So instead of throwing them immediately, I am going to return the message of each of these validations, and only then I'm going to process them, or I'm going to check what I have. All right? So what I have to do here is, instead of throwing the error, I'm gonna check the validation, or check the what I need to check, and if it fails, I'm gonna throw this message, or sorry, I'm not gonna throw, I'm gonna return the message. Otherwise, I'm gonna return an empty message. Okay, and I can delete this code here because I do not need this anymore. So again, I'm gonna validate the password. If this validation does not succeed, then I'm gonna return the error. Otherwise, I'm gonna return an empty string. Okay. In this case here, it's gonna actually, if the length is less than 9, it's true, and this first part here is gonna be returned, right? This message. If you're not familiar with this notation, with this question mark that I have in this line and the column here, this is a shortcut for this following expression. This is just a shortcut for the if-else statement. So what I have in this line here, line 24, is equivalent to this. So if password length is less than 9, then return password should be larger than 8, else return empty string. Okay, but this is few lines of code. Okay, so this is much larger. Most of the programming languages offer this shortcut for writing this expression. So this is called the ternary expression. All right, and it can be also broken down like this for readability purposes. All right. In this case, I'll just keep it one line. So let me get rid of this remaining. So if the password length is less than 9, I'm gonna return the error. Otherwise, I'm gonna return just an empty string. Okay, I'm gonna do the same for this password lowercase verification. So I'm gonna do return, and I'm gonna do this here. So if password to lowercase equals password, then I'm gonna give the error. Otherwise, I'm gonna return the empty string. Okay. Also notice that I am not returning the type of error anymore. This is just for simplicity. In what we're gonna say, real world case or in a real world project, I would prefer to maintain the error type, not throwing, but using the not throwing the error, but instead just returning the error type like this. Oops. Just because having a specific type or specific object representing the error makes it easier to manage or to handle certain situations. But for the simplicity of this kata, I'm just returning the string itself. Okay, so I'm gonna do the same here. Return, do the verification. Return the error, otherwise empty string. And at last, the at least one number verification. So again, return, validation, and if it fails, I'm gonna return the error message, otherwise empty string. Okay. I also noticed that I accidentally added the parentheses here, which in this case doesn't change. You can have the parentheses, but there's no reason to have the parentheses there, so I'm just going to remove them. Okay, so let's go back to our validations array and the errors array. So here, the result of this mapping should be a list of strings, right? I'm calling each of the validations with the password, and if they fail or they pass, I'm gonna receive a string, either an empty string or the string containing the error. But I want only the ones containing the error. So what I'm gonna do here is filter the results that I receive. So I'm gonna filter the results that I receive, saying that I only want the ones that are not empty string. Okay. Another way to do this would be to say error.length greater than 0. So we're saying that the string must be a length greater than 0. I'm gonna maintain it as is, like this, just for personal reasons, really. All right. So now I have an array containing all the errors that my password verification received. What I have to do next is check the number of errors that I have. Okay. So remember that we are allowed to pass 4 validations, and the password should be okay. But because we have 5 validations, it means that if we have one failure, then it's fine, because then it's 4 validations passed. But if we have more than one failure, it means that at least 2 or more validations failed. So in this case, we should throw an error and we should not proceed with the validation. So what I'm gonna do is, if errors.length is greater than 1, then I'm gonna throw an error here inside this if statement. Okay, so I'm gonna throw error, and what's gonna be the message here? The message that I want in this case, the Kata doesn't specify. Let's go back to the README. The Kata doesn't specify what is the error if more than one validation fails. What I will do, and what I would like to do, is to accumulate the errors and display them. Could be with a comma, it could be with whatever. Okay, so what I'm gonna do is errors.join. So remember, this is an array of strings, each string being an error. So the documentation says that if we do not specify any parameter to the join method, it's gonna separate the message or the strings with a comma, which is fine. Let's leave it as is. Okay, so this errors.join is gonna collect each of the strings in this array of errors, and it's gonna join them with a comma. Okay, so I'm gonna throw an error containing that specific message. All right, I know this was a bit too much of a refactoring, but remember that we are actually changing the behavior of the code that we already had. And it was quite a big change to accommodate the next feature. So I'm gonna save these changes, and I'm gonna run my tests again, and let's see what happens. Okay, there's a lot of error messages here. Hang on a bit. Let's go up and let's see what we have. All right, so we still don't have the password, the last test passing, which is our goal in this change. Let's see why. It should be the last test executed. And it says validations is not defined. So reference error, validation is not defined. So we may have put the wrong name of our constant there. Aha, let's go back to line number 5. So I actually accidentally named the array validation, where it's actually validations like this. Okay, so let's save it again. Let's run the test. Let me clear first this this console, and let's run the test again. Now it says that actually 3 tests passed, so that's looking better. Okay, so now we have our last test passing. So it means that we managed to implement the feature, but look at this, we have 4 failing tests. So we changed the code to accommodate a new feature, and we ended up breaking 4 tests. In this, sometimes we cannot predict all the tests that are gonna fail when we change the code. We cannot predict what the changes are gonna cause to our code. But when we have tests covering our code, that puts us in a much better place, because then we can see where our code is breaking or where our code is misbehaving, and then we can go and fix these problems, whether it means changing the test or whether it means changing the implementation. So let me clear my console again. Let's go back to the code. Let's check the failing tests. And the password should not be null. It was passing just fine. The failures that we had was between these 4 tests here. And it makes sense why they are failing, because we are calling the password verifier, and we are expecting an error with these specific messages. But remember that we are not throwing specific messages anymore. We are collecting them and we are joining them with commas. So if, for example, any of these strings fails more than one validation, we're not going to be just error password should have one number at least. We're going to have more than one message here. Okay. Unfortunately, with this framework, with the Jest framework, there is no way for us to check parts of a string. We can only check on the full string, or on the full, in this case, in the full error. But I don't want to be that specific, because right here we are only concerned with one specific error, and it's the same for this for all of the other tests. We are always concerned with one specific error, so we should not be writing down all the possibilities or all the errors that is contained within this error message. Okay, so because Jest doesn't provide us a nice way to do that, I'm gonna fall back to the old try-catch way. Right, so what I'm gonna do here is use a try-catch, and inside my try block I'm gonna execute the function verify, and in the catch block I'm gonna check on the error, which in here I call just E. That's just standard way to call the error that's captured by the catch block. I'm gonna check on this on the message that's contained within this error, and check if the message that I'm expecting is actually there. Okay, so let me first get this password verify here. I'm gonna remove it from here. I'm gonna put it here. So this should fail the validation. So we should expect the catch block to be triggered. And what I'm gonna do is just copy this whole line 16 inside the catch block, and I'm gonna modify it. Okay, so I'm gonna get the error dot message. So this is gonna give me the message within the error class, and instead of to throw I'm gonna type to contain, and I'm gonna pass just the string. Okay, so let me just remove some empty lines here. So going back again, we are expecting that the message of this error contains the password should be larger than 8 characters. Let's run our test now and see how far we got. Alright, now it's saying 4 tests passed. Let's scroll up and see if it actually passes. So you see right here, so the password should be larger than 8 characters, now pass. So it means that we can reproduce the same behavior or the same procedure with the other failing test that we have. Okay, so let's carry on to the next failing test, and we're gonna use the same try catch. So try catch. I'm gonna copy this whole line here in the catch block, and I'm gonna slowly modify it. First, I'm gonna take this verification and I'm gonna put it here in the try block, and I expect the error to be thrown, so it's gonna be called by the catch block, and I can proceed and check that the message contains this this specific error. Let's save. Let's run the test again. I'm gonna first clear my console. I'm gonna run the test again. And now we should have 5 passed tests. And if we scroll up, indeed, the password should have at least one uppercase letter, now passes. So let's proceed with the other remaining failures. Gonna write the try catch. Gonna copy the verification inside the try block. Check the message to contain this specific error. Alright, save, run the tests. Good. Now we're down to only one failure. I'm gonna finally fix this last failure. So try catch. I'm gonna copy, and I'm gonna put the verification inside the try block, and I expect that the error message contains the specific failure. Let's run the test, and awesome. Now we have half our tests passing again. Now we are good, we're on the green. So what do we do? We're on the green. We commit the code. And also notice that I'm only committing the code when all my tests are passing again. So password should be okay if it passes all validations. Sorry, if it passes at least 4 validations. Good. Now let's go back to our README file and see what's the next feature. And as you can see here, the next feature is that the password is never okay if item 1.4 is not true. So this is item 1.4. Password should have one lowercase letter at least. So what we have to do here is, if this validation fails, it should throw the error and it should not proceed with the other validations. So this is very similar to the not no validation, right? So basically we're saying that this must be true. We cannot proceed with the validation if this one fails. And this is exactly what we were doing before we did all this refactoring. So we know how to fix this. We just need to go back to our previous code for this specific validation. Okay, so let's go back to the test, and let's just confirm what was the item 1.4. So the item 1.4 is for the lowercase letter. Okay, let's go back to the test, and let's remove this try catch block. I know this is a bit annoying, but that's exactly how it is. So let's bring this validation back. Let's remove the try block, the try catch block. And again, we have to verify that whenever I have a password which doesn't have at least one lowercase letter, I should or I must throw the error. Okay, I'm gonna run my test, and I expect this test to fail, because as we know, now the password's not, the error is not immediately thrown, it's actually accumulated. So let me run my test again. Good. So we have the test breaking again. So what we have to do is go back to the previous implementation that we had for this specific password. All right. So what I'm going to do here is bring this validation up here to the same level as the not no. All right. And I'm going to go to the implementation of this lowercase validation and bring back the way it was before. So if the password uppercase equals password, I'm gonna throw an error containing this message. Otherwise, I don't need to do anything. Okay? Let me save this code, execute the test. I'm gonna clear my console. I'm gonna execute the test. And once again, we have everything green. So I'm gonna commit. Password should fail if does not contain, or actually password validation should fail if it does not, if password does not contain at least one lowercase character. So let's push the code, which we forgot to do in our previous commit. Good, we pushed the code, and let's go back to our description. So we have number 3 implemented, which brings us to number 4 only. Number 4 says, assume each verification takes 1 second to complete. How would you solve items 2 and 3 so tests can run faster? Items 2 and 3 are the ones that we just implemented. So item 2 again says that we should have at least 4 validations to be true. And test in item 3 says that 1.4 should always be true. Looking back to our implementation, what we have here is this is number 3, and all of this here is number 2. Looking at this code, if each of them takes 1 second to complete, I think we've got to a very good position of this implementation, because we put the at least one lowercase character validation all the way to the top, so we are not including it to this array of validations here. So we know that if it fails, none of these validations is going to proceed. Okay, and for the second validation, that at least 4 of the password should it passes if at least 4 of the validation passes. By bringing 2 validations, 2 of the main validations outside the array, we are already minimizing the possibilities of errors that we have. So I cannot see another way to improve this code, or a way that would actually make a huge difference, considering that each validation takes 1 second. I think the way that we drove our implementation was already towards what the 4th feature, the 4th requirement of our Kata was aiming for. So it seems like that we actually jumped ahead of the Kata, which is good. Okay, I can see one tiny refactoring that we can do here, which is not strictly necessary, but I can quickly show. We can move this constant outside the verify. And let's see what the error says. Okay, so it seems like that actually we cannot use this constant outside. Alright, so this is the limits of my JavaScript knowledge. No worries. So let's keep it as is then. This seems like a code that's good enough for us, and to complete our kata. And that is it for now. Our kata is finally done, and I really appreciate your time. And once again, if you have any questions, don't hesitate in contact me on Slack. And if you would like me to solve any specific code, any specific kata, let me know. And I will try to do my best to walk step by step with my thought process and breaking it down in smaller steps so it makes it easier for everybody to understand. Alright, thank you very much, and I'll see you next time.